Hello everyone, this is what we want to do in the last session of the Mechatronics workshop. First, let's check if the Haplet board is recognized by our computer. As you can see in the device manager on my computer, the Haplet board is recognized as an Arduino Due on COM port number 3. Now let's run MATLAB as an administrator. MATLAB is launching now. To check our MATLAB installation, let's type VER in the command window. We can see all the different products that are installed within the MATLAB package. For running our Haplets on our machine, we actually need MATLAB, we need Simulink, we need a real-time Windows target. In versions later than 2014A, this is called real-time desktop target, which works for both Windows and Mac operating systems. Last but not least, we need Simulink real-time also. The last check we need to do is to type RTWho, and this shows if the real-time products are configured on our computers. Now let's open the Haplet 2D template to test the connection between Simulink and our Haplet boards. When you open the template, you see a block called Haplet and an animation block. The Haplet block itself has two main components. The first is the device kinematics function, and the second is the communication block. The communication block uses packet inputs and outputs. Let's open the packet output block. If it's your first time running this on your computer, you need to choose Install New Board, go to Standard Devices, and choose Serial Port. After that, make sure to choose the correct port number. On mine it was COM3, and also choose the correct baud rate, 115200. Now let's put the Haplet in initialization pose with the two arms open at 180 degrees and reset the board. Now we can run the Haplet 2D template in external mode. This starts the communication between Simulink and the board, receives the angle, and updates the animation window as we move the Haplet arms around. We can also test the motors. Let's write a force of, for example, 0 and 1, 0 in the X direction, 1 in the Y direction. As soon as we press enter here, we can see that the arms are pushed upward in the positive Y direction. Now let's reset the force to 0. Yeah, now we can move it around freely. Let's stop this and close the Simulink model. Okay, now let's see what our first project looks like. Our first project is about creating a haptic pong game. To do this project, we start with the Haplet 2D template and we program the functionality we want. Here we just need to add the dynamics of the ball that falls under gravity and hits the racket at the endpoint of the Haplet. This is the dynamics block you see here. Now we can run. As you can see, whenever the ball hits the racket, the two lights of the motor ports on the board turn on. This shows that the motors are turned on to generate the force you need to feel when the ball hits the racket. As you can see, this is an interactive simulation. Okay, now we stop the simulation, we reinitialize the device, and let's get ready for the second project. The second project is about drawing shapes using a haplet. This task represents an important topic in robotics and industry. This is called path planning. For path planning, we need to generate a desired trajectory and we need to design a controller to accomplish that. Here I have used a lemniscate path. A lemniscate is just a figure of 8 shape, and as you can see when I'm running this simulation, you can see that the end effector of the haplet is generating this figure of 8. Okay, now what we can do is to actually place a paper beneath the end effector, and I've already attached a pen to the end effector. So now if we rerun the program, it actually draws that shape on the paper. Thank you very much for listening and watching this video.